All right, let's just dive right into this explainer. Today, we're going to completely transform how you build, optimize, and orchestrate your containers. Seriously, if you've ever sat there staring at your screen, waiting ages for an image to build, or if you've totally tangled yourself in local networking issues, well, welcome to the Docker Level Up journey.
We are taking a journey today, going from just desperately trying to get a bloated, chaotic container to run, all the way to deploying really sleek, multi-stage networks. Now, I know the Docker ecosystem has a ton of moving parts, whales, octopuses, shipping containers stacked to the absolute sky, and it can kind of feel a bit overwhelming at first. But stick with me, because by the end of our time together, you're going to have a crystal clear framework for truly professional-grade containerization. So here's our roadmap. We're going to start with core Docker concepts, then move into writing better Docker files, unlock the speed of the Docker build cache, dive into shrinking your images, and finally wrap the whole shebang up by mastering Docker Compose.
Okay, Section 1, Core Docker Concepts, Defining the Fundamentals.
To kick things off, we really need to clearly separate two foundational concepts that honestly get confused way too often in the wild. First up, the Docker image. By definition, an image is a lightweight, standalone, executable package of software. It literally includes everything you need: your code, the runtime, system tools, system libraries, settings, you name it. The best way to think about it, it's essentially your static, immutable blueprint. Once the architect draws it, that blueprint does not change.
And then, on the flip side, we have the container. Now, a container is that exact blueprint actually brought to life and running on your infrastructure. It's a runtime instance. And the golden rule here, this is absolutely crucial, is that containers should be highly ephemeral. Basically, that means you should treat them like disposable assets. They need to be able to be stopped, destroyed, rebuilt, and completely replaced at a moment's notice, all with zero loss of data and absolutely no manual setup required. Moving on to Section 2, Writing Better Docker Files, the Blueprint.
Now, what's really interesting here is how we actually write the instructions to build those static images. Think of these essential commands kind of like stacking blocks. You've got from, which establishes your starting point, your foundation. Then label steps in to organize your metadata. Run executes your actual commands, like installing required packages. CMD provides the default behavior for when the container finally wakes up and starts. env securely sets your environment variables, copy seamlessly drags your local files right into the image, and finally, workdir sets up your stage, giving you a nice clean directory to operate in. But here's the catch. These instructions stack sequentially. If you just throw them in indiscriminately, you're going to cause massive bloat, because every single instruction creates an entirely new layer in your final image stack.
And honestly, this brilliantly illustrates the right way versus the wrong way to use that run command. So look at the left side. Separating your update and install commands traps you in this awful web of outdated packages. Why? Because the build is just going to reuse the old update layer from the cache, and your install command will end up fetching outdated and potentially vulnerable software. It just doesn't know any better. Instead, you always want to do what's on the right. Combine them into one single step using a double ampersand. That ensures you are pulling fresh, secure packages every single time that layer actually executes.
All right, Section 3, the Docker build cache. The need for speed.
If you truly want that need for speed, you absolutely have to understand how the build cache actually works. It's actually pretty predictable, operating in 3 steps. Remember those stacking blocks we talked about? Well, think of it like a physical tower of blocks. If you pull out a block right in the middle, every single thing resting on top of it comes tumbling down and has to be completely rebuilt. So if you change a source code file, the copy command immediately invalidates the cache for that specific layer, forcing Docker to execute every single instruction below it right from scratch. That right there is exactly why your golden rule is to put frequently changing instructions, like say your application code, as far down, as close to the bottom of the Docker file as possible.
Okay, Section 4, Shrinking Your Images, the Great Shrink. Let's look at a real-world weight loss makeover from a DEV community case study. So this dev team was dealing with just incredibly sluggish, painful deployments. The main culprit? Their image was a staggering 1.2 gigabytes. I mean, wow. That meant agonizingly slow builds, super inflated cloud storage costs, and these massive, heavy network transfers every single time they pushed even a simple update. But check this out. By applying just a few smart optimization techniques, they managed to slash that bloated beast down to a very lean 250 megabytes. That's nearly an 80% reduction in size. It literally transformed their CI/CD pipeline efficiency overnight. So how exactly did they pull that off?
Well, the biggest drop came from simply swapping out heavy base images, like a full Ubuntu install, for a minimal Linux distribution like Alpine, which clocks in at under 30 megabytes. And they paired this up with multi-stage builds. Think of a multi-stage build kind of like a workshop versus a showroom, right? In stage 1, the workshop, you use a heavy image with all your messy compilers and tools. But once your code is actually compiled, you only take the shiny finished product into the clean, tiny Alpine showroom in stage 2. You just leave all that heavy tooling behind.
Seriously, if you adopt the specific optimization checklist, your cloud costs are going to plummet. First things first, use a Docker ignore file. Do not let local temp files sneak into your build context. Next, combine those run statements to minimize your layers. And please, stop hoarding dependencies. If your app doesn't strictly need it to run, kick it out. You can even run automation tools like Docker Slim to just ruthlessly strip out unused binaries. Audit your images regularly, and you watch all that bloat just disappear.
And that brings us to Section 5, Mastering Docker Compose, Bring It Together. Now that we've got these highly optimized individual containers, it is time for our final level up. We know how to run one container perfectly well, but what happens when you need an API, a Postgres database, and a MongoDB instance, and they all need to be talking to each other locally? Because let's face it, in modern development, applications almost never sit in isolation.
Now sure, you could try chaining together these massive, messy CLI commands right in your terminal, carefully mapping out ports, manually passing database URLs, but if you do that for 3 or 4 interconnected services, it quickly becomes this tangled mess of digital cables. It is an absolute nightmare to maintain, and frankly, it's almost impossible to hand off to another developer without something breaking. Instead, we use a single Docker Compose YAML file. This elegantly defines your entire network of dependent services in one go. As mapped out here, we just explicitly list the services, their target images, and their port mappings inside one clean, readable file. It's basically infrastructure as code for your local machine. You literally just type one command, Docker Compose up, and your entire environment springs to life in perfect harmony. Compose just handles all the complex networking for you automatically.
So, you now have the blueprint for true, professional-grade containerization. Which means, here's the question you really need to ask yourself today. Just how much bloat is hiding in your containers right now? Take a look, go audit your Docker files, start implementing those multi-stage builds, learn to bust your cache effectively, and orchestrate the whole thing with Compose. Take these techniques back to your own codebase and just watch your deployments fly.